Okay, so we have already discussed what is an ordinary annuity. It's payments or receipts that occur at the end of each period. Now again we will look at an example. So suppose you save 1000 per year at the end of each year for 3 years and earn 5% interest per year. How much will you have at the end of 3 years? So again, how can you differentiate this, that this is an annuity or whether this is a single cash flow? Look for the word per year. Per year का मतलब होता है हर साल कोई चीज़ हो रही है. So it's repetitive. So suppose you save 1000 per year. So you're going to save 1000 every year and you're saving it at the end of each year. So this is telling you that this is an ordinary annuity. But you cannot be completely sure because you need to see that is the third characteristic there. Do you know when the payment is going to end? So let's read ahead. Per year at the end of each year for 3 years. So you know that the payment is for 3 years. So it's not the payment because you're saving, sorry. So you know that you are depositing the amount for 3 years. So the defined time limit is over there as well. So all three characteristics are there now. So if we make it at a timeline, the payment is going to be at the end of each year. So this is the start of first year. The point 0 is the start of the first year. It is right now. And over here, the first year ends. The points represent the end of the year. So at the end of the first year, you have 1000. At the end of the second year, you also have 1000. And at the end of the third year, you are also going to save 1000. So you have saved 1000 at the end of each year for 3 years. Now this 1000 is going to earn an interest of 5% per year. And the question is that how much will you have at the end of 3 years? So what is the future value at the end of the third year? This is basically your complete question. Now first we will use the single cash flow formula and solve this question. So note over here that the formula that you have studied so far, the single cash flow formula, is applicable in every case. So even if you're dealing with single cash flows, even if you're dealing with an annuity, you can still use that formula. But later on I'm going to introduce another formula for annuity because that formula will make your calculations shorter. Okay, so first let's use the single cash flow formula. So I'm going to open a note for this. Okay, so this is our timeline. We want to know the future value at this point 3 and the interest rate is 5%. Now this is a formula that you have studied so far to find out the future value. Now this is a single cash flow formula. Let me make it a bit neat. Now this is your single cash flow formula, which means that in this formula each cash flow needs to be treated separately. So forget about the other two cash flows right now. Let's just look at the first 1000 cash flow. So the present value is 1000. The interest rate will be 5%. The question is, what should be the end? Usually students answer that the end should be 3 years, but think again. If the 1000 value would have been over here, then n would have been 3 because that would mean 1, 2, 3. But you are not getting the 1000, you're not saving the 1000 right now. You're actually waiting for one whole year, and at the end of the first year you're going to save this 1000. So if you're saving the 1000 at the end of the year, that 1000 is not going to earn any interest during the first year, right? Let me just erase this extra. So if you look at the first 1000, it will earn interest for 1 year and 2 years. It's getting interest for the first year and the second year. So the n over here will be 2. Similarly, we will go on to the next cash flow. So for that, we need to plus 1000 in it. So because now in our bank account we added another 1000, the interest rate is the same. But again, you need to think how many years it's going to get interest, given that on the third year I want to check my bank account balance. So if you're depositing it at the end of the second year, so you'll get no interest during the first year, neither will you get any interest during the second year. Because you deposited the amount at the end of the second year, you will get interest only from the start of the third year till the end of the third year. So you'll get interest for only 1 year in this case. Now moving ahead to the last cash flow. Now if you look at the last cash flow, it is at the end of the third year, and you want to know what is your future value at the end of the third year. So it's like just depositing 1000 rupees and then checking that what is your bank account balance. So this cash flow doesn't get any time to earn any interest on it. So over here, if you want, you can use time 0, because this one is going to earn no interest on it. Or if you want, you can simply ignore this and just write 1000 over here, because this will become 1. So if you solve this, this will become 1 because it has a power of 0. So anything that has a power of 0 takes a value of 1. So this is the same as just writing simply 1000. So if you want, you can just simply write 1000 only over here. Okay, so if you solve this, you will get the answer. So this has a value 1102.5. 1050, and this is 1000. $3152.5. This is your future value. So let's go up once again. What's happening over here is, let me first erase this, all the mess that I have created. So you wanted to know the future value over here. Now what's happening is that you deposited this 1000 1 year later. You deposited this 1000 1 year later, so at the end of the first year, it will get interest for only 2 years, and 2 years later, its value will become 1102.5. 1102.5. Similarly, now you know that this value will become this 2 years later after getting compound interest. Now you deposited second 1000 at the end of the year 2, so it will get no interest during the first year, no interest during the second year, but it will get interest from the start of the third year till the end of the third year. So it will get interest for 1 year only, and its value will become 1050. Plus you will deposit another 1000 because you deposited at the end of the third year. It has to complete some time period for it to earn interest. Because you deposited at the end of the third year, it will get no interest at all. So you just deposited the 1000 and you checked, okay, what's my account balance now? So if you sum all of them, so if you add all of them including the 1000, the total future value is 3152.5. So this is how you calculate the future value of an annuity. But over here you can see that this seems to be very long. Right now you just had 3 years, so you did it 1, 2 and 3 times. If you have, so let's say 20 years, so that would mean you will have to do this 20 times. So the calculation will become quite long, so it will keep on going. Similarly, it can be 50 years, 60 years. So the questions can be quite tedious. But over here, because you have a pattern, and the pattern is that the cash flow does not change, the interest rate does not change, and you know when the payment is going to end, you can actually use a formula that is more easier to use and that will give you the answer quicker. So let me go to that formula and to close this. So these are your annuity formulas. The first one is to calculate future value and the second one is to calculate present value. The FVA means future value annuity. N is the number of years. PMT stands for payment. So these are your equal cash flows. PMT means payment. R is the interest rate. And N is the number of years. This is your future value annuity formula, and below that you have the present value annuity formula. Over here also PMT means payment, R is still the interest rate, and you have a negative N over here, okay, because you're doing discounting, so your N is in negative. So let's see how can we apply this formula in our previous example. So in that we wanted to know the future value of the PMT. So let's go back. Now if I want to apply that formula on this question, my PMT is 1000. So your PMT are your equal cash flows. The interest rate was 5%, and your N over here you will just take the number of years, the annuity payment. So there were 3 annuity payments, so you will take 3 over here minus 1, and R you have 0.05 once again. So let's solve this. So first I'm going to solve this bracket. Okay, I've corrected this. Over here I had it in minus by mistake. This is plus. Okay, now if you solve the bracket, you are getting 3.1525. This 3.1525 is called your future value annuity factor. Okay, this is also called this future value annuity factor. Now if you multiply this by 1000, again you get the same answer. And you can see that you don't have to put the 1000 again and again and again over here. You just place it one time and you use the power over here, power 3, and you get the direct answer. So this is what the annuity formula does for you. It actually shortens your answer. So you can still use this formula. Okay, this formula is applicable in each and every case, but if you use this formula, your questions will become very long, the answers will become very long. So a better way of solving those questions is that you should use this annuity formula over here. So now we're going to practice the usage of this formula so that you understand it even more. So moving ahead, suppose you save 4,000 per year at the end of each year for 3 years and earn 5% interest per year. How much will you have at the end of 3 years?